We're going to do a quick mini lesson to look at how we can sketch a conic, just a sketch when it's in polar form. So we have two general equations that we can use for polar form of a conic. We have R is equal to E times P over 1 plus or minus E sine theta. And then we have the same equation over here, but we just changed that E sine theta to E cosine theta. The eccentricity, that's our value of E, that tells us how far we deviate away from the shape of a circle. When E is exactly 0, then our conic is going to be a circle. And then the farther that E gets away from 0, the shape is going to change into different conic sections. So when E is between 0 and 1, not including 0 and 1, but between 0 and 1, then we're going to have an ellipse. When E is equal to 1, we're going to have a parabola. And when E is greater than 1, we'll have a hyperbola. P, that's this P right here. P is going to be the distance from the focus to the directrix. Let's take a look at the parabolas first. We have 4 different variations here. Remember, our 2 general forms that we could use is EP1, and then we could have plus or minus E cosine theta or sine theta here. And then actually we can break that down into 4 variations because we have plus or minus, and then we could have sine or cosine. When we have sine in the denominator with a plus, that means we're going to have a parabola that opens down. The focus is going to be at the origin or at the pole. And then P tells us the difference between the focus and the directrix. So if this is the focus here at the pole, then it's going to come out to y equals P, whatever that P is here that we determine. Now, if we have the version of the polar equation where we have a minus E sine theta, then that's going to be that it opens up. My focus is going to be at the pole, and my parabola is going to come down where the vertex is below the pole, and our equation of the directrix will be y equals negative P because now we're below the x-axis. Now, looking at when we have cosine in the denominator, the cosine indicates that we're opening either to the right or to the left. It's going to be a horizontal major axis. When we have a minus E cosine theta, that means the vertex is going to be to the left of the pole. Here's our focus. That's our origin. Our vertex is going to be here, where my laser pointer is. And then our directrix, because it's coming to the left of the pole or the left of the origin, and it's a vertical line, that directrix is going to be x is equal to negative P. And then the last version of this, if we have a plus E cosine theta, it's going to open left. Our vertex is going to be to the right of the focus. And then our directrix is going to be x equals P, where P is positive because now we're looking at the directrix as being to the right of the pole. Let's look at an example of a parabola in polar form. We have R is equal to 5 over 3 minus 3 cosine theta. Now, in order to identify the eccentricity, the E, I have to put it in the form that we had in the first slide, where in the denominator we have 1 minus, and then our E times cosine theta. So I have to divide the top and the bottom by 3 so that I have it in this form. Now, when I do that, I get 5/3 in the numerator, and I get 1 minus cosine theta in the denominator. Now, because this is a cosine theta down here, I know it's going to either open to the right or to the left. The minus right here indicates that it's going to open to the right because our vertex is going to be to the left of our pole. So here's our focus point for the parabola. Here's our vertex that's to the left of the origin. And then our directrix is going to be the distance of P from the focus out. Now to find P, we can see that our eccentricity is 1 because the eccentricity is what's in front of the cosine once we get it in the correct form. So that tells us that we're dealing with the parabola. Now, the E times P, that's the value in the numerator. And since I know E is 1, then P has to be 5/3. So this tells us how far out to come from the focus for the directrix. Now, because the vertex is on the left side and the focus is here on the inside of the parabola, which is the pole, we know we're going to be looking at the directrix here on the left side. So that's going to be equal to, x is equal to 5/3 because we're going to come out 5/3 to the left. Let's take a look at the ellipse now. So when you determine that your E, or your eccentricity, is between 0 and 1, that means you have an ellipse. And we have our 4 different versions here. When the formula has cosine in the denominator, the major axis is going to be running horizontally. When the sine is in the denominator, then the major vertex is going to be running vertically. Now, the difference between the plus and minus tells us where the directrix is. If we plot our first focus point at the origin or at the pole, remember an ellipse has 2 focus points. And it should be symmetric, but I have poor drawing skills, but imagine that this is symmetric. Now, when this is a minus cosine, that means the directrix is going to be to the left of that focus point that's at the pole. So that means whatever we determine P, that value of P is, that's going to be x equals negative P because we're looking at a vertical line for the directrix. And the value of that x is going to be negative because it's to the left of the origin. The same idea goes for when we have a plus cosine theta. The plus indicates that our directrix is going to be to the right of the pole. And when we draw the first focus point, that's going to be on the origin or the pole. And the second one is going to be to the left. And then our value of P is going to give us our directrix. And because the directrix is a vertical line to the right of the origin, it's going to be x is equal to positive P. Whatever that value of P is, it's going to be positive. So now with the sine thetas, if you have a sine in the denominator, then your major axis is going to run vertical. If you have a minus E sine, that means your directrix is going to be below the pole. So when we draw the first focus point on the pole or the origin, the second one is going to be above it and the directrix will be below. So because this is a horizontal line and it's below the x-axis, we're going to have our directrix as y equals negative P. And then when we have a positive sine theta, that means that our directrix is going to be above the pole or the origin. And when we draw our second focus point, that's going to be below the origin. And because our directrix is a horizontal line and our distance from the focus to the directrix is P, our directrix will be y is equal to positive P. Okay, let's look at an example of an ellipse. So we have the polar equation r is equal to 6 over 2 minus cosine theta. Now I have to put it in this form before I identify what my eccentricity is. So I have to make sure that this value in front is a 1 in the denominator. Right now it's a 2, so I'm just going to divide everything by 2. So what I get is a 3 in the numerator, and I have 1 minus a half cosine theta in the denominator. So now I know what's in front of this cosine. That's my value of e, which is a half. And that tells me that this is an ellipse, because an ellipse is when our e is between 0 and 1. Now I also have to find my value of p. And since I know my eccentricity is a half, and I know that my e times p is 3, so when I figure out what p is, I'm going to get 6. So that means the distance from the focus to the directrix is going to be 6. Now, because there's a negative down here, that means my directrix is going to be to the left of the pole or the origin. So here's my focus point. My second focus point when I graph it is going to be over here, symmetric distance. It just doesn't look symmetric. So I have whatever this distance is here from this focal point to the vertex is going to be the same from this focal point to this vertex. And then the directrix will be to the left of the origin. And because it will be a vertical line here, it's going to be x equals. And our p is 6, but we have to throw that negative in there because we're looking at the vertical line that's to the left of the origin. So our directrix will be x is equal to -6. Let's take a look at our last conic shape. We have hyperbolas, and of course we have the 4 different versions here. 2 of them with sine, 2 of them with cosine, and then we have our versions with the pluses and minuses. When the denominator has a sine, so this one and this one, our major axis is going to be vertical, so it's going to be running up and down. And of course, our foci is going to be on that major axis. Now, where this is a plus, that means the directrix is going to be to the, or I should say above the pole, and that will give us our directrix with the value of p. This is a horizontal line, so my directrix is going to be y equals positive p. When this is a minus, that tells me that the directrix is below the pole or below the origin. So that means I'm going to have a directrix that has an equation of y equals -p. When we have cosines in the denominator, then we know that the major axis is going to be running sideways, horizontal. So now my hyperbola is going to open to the right and to the left, and my foci is going to lie on that major axis. But the plus tells me that the directrix is going to be to the right of the origin, meaning it's going to be positive. So where we have a directrix on this, for this example, it's going to be a vertical line at x equals positive p because it's to the right of the origin. When we have a minus e cosine theta, that means the directrix is going to be to the left of the focus point, or the pole, I should say. And because it's to the left, whatever our value of p is, we're going to get that equation for the directrix is x equals -p. All right, our last example, we're going to look at an example for a hyperbola. We have this equation here. R is equal to 6 over 1 plus 3 cosine theta. Now, first we need to find our e, which means we have to make sure there's a 1 down here in the denominator that's by itself, not with the cosine. So we have that here. So it's already set up for us. So I know that my eccentricity, my e is 3. And because it's greater than 1, I know that this is going to be a hyperbola. Now, the numerator is my e times my p. So since e times p is equal to 6, and I know e is 3, then p has to be 2. Because this is a cosine here, I know that my major axis is going to be horizontal. So that's going to be this way here. And because this is a plus with the cosine, that means that my directrix is going to be to the right of the pole or the origin. Here's our first focal point, and our second focal point is using symmetries on the same side opposite of that first one. And then the directrix is going to be 2 out from the focal point. So I'm going to come out 1, 2, and because my directrix is running vertically, this is going to be a directrix of x is equal to 2. This is going to be a positive 2 because it's to the right of the origin.